The Earth Sciences and Geological Engineering Research Group represents a collaboration of researchers from the universities of Jaén and Granada, as well as other institutions associated with the Andalusian government, and has its headquarters at the Scientific Technological Campus in Linares. These facilities signify the University of Jaén's clear commitment to research, development, and innovation. The group has the following lines of research: groundwater contamination and vulnerability, hydrogeochemistry of mining areas, alkali and acid drainage, hydrodynamic and hydrogeochemical analysis of aquifer systems, reactive transport modeling, geophysical and geochemical prospecting in hydrogeology, mining, geotechnical engineering, and the environment, geological risks, application of isotopic hydrology techniques, geochemical characterization of soils and sediments, study of the Ordovician Silurian in the Central Iberian Zone, Sierra Morena. Our group is devoted to studying water resources, principally groundwater, and measuring not just quantities, but quality as well. Today, for example, we are analyzing the content of dissolved metals in a smelting waste dump in a former mining area. We're using a multiparametric probe, which allows us to continuously record the pH, salinity, and levels of certain substances that are highly hazardous from the environmental point of view, like nitrates and ammonium. Among the research team's most important equipment are ground-penetrating radar, electrical tomography, well logging, and a laboratory for water analysis. Ground-penetrating radar, or GPR, is an indirect research technique based on the emission and propagation of electromagnetic waves into the ground. Its advantage over other techniques is that it provides greater resolution, but its range is much shallower. In this case, for example, we are measuring the possibility of finding buried structures in this building, which will be important during renovations. Here we see that there are a number of beams that the architect will have to take into account. The research group has geophysical test equipment for well logging, including a winch that allows us to reach 500 meters deep. And using a pulley and a cable, we insert probes into the wells to measure the various hydrogeological parameters that we're interested in. Here, in the field, we are doing a study of geophysical prospecting for groundwater, an ideal method to find aquifers that can be used for irrigating olive groves, among other things. To do this, we use a geophysical technique called electrical resistivity tomography, in which we have a number of electrodes in the soil. We inject a current, and then measure the electrical potential using a scanner. In this way, we determine the electrical resistivity, which is an inherent property of the rocks, to create a geophysical model. Later, in the laboratory, using the geophysical model, we will interpret these results to recreate the real model that we're trying to study. We have laboratories where we can determine the major and minor constituents of the water and all the parameters that are needed to do a complete hydrochemical study, including levels of environmentally dangerous elements such as heavy metals and arsenic. These data will allow us to then analyze not only water quality, but also determine its origin and what processes may be affecting it. With this information, we will be better able to protect these water sources from pollution. Our work revolves around three main lines of research: geophysical prospecting, applied to hydrogeology, mining, and archaeology; evaluation and management of water resources; and environmental quality assessment in mining areas, focusing mainly on water and soil pollution. Business sectors and/or public entities to whom the research is directed: Ministry of Environment, Department of Public Works and Housing, Ministry of Innovation, Science and Enterprise, water boards, provincial and city councils, and companies related to geological resources and the environment.